Hey everybody, Sukani here. Today we're going to be taking a look at how to solve this problem. A block of mass m moving with a speed of v naught on a frictionless horizontal surface collides inelastically with a stationary block of mass 2m. After the collision, the two blocks stick together, of course since it's an inelastic collision, and slide a distance d before coming to rest due to a kinetic friction force of magnitude f subscript k. Find the expression that gives the initial momentum of the system with respect to the above variables. So right off the bat, I know this is going to be a momentum question, and I know that we are supposed to find the initial momentum. So this is what we are supposed to find. Now, there are two essentially parts to this problem. The first part is that we have a small block, and then it collides into this block right over there, and this exemplifies conservation of momentum because there is no net external force because it is frictionless. The second part of this problem is that these two blocks, they combine into one very big block, let's say, and then on this surface there is some friction and it travels for a distance d before finally coming to rest. This part, let's just get on and apply that conservation of momentum. The conservation of momentum formula for inelastic collisions would be this equation right over here. Now let's just substitute those values, and then we don't know the final velocity, but we can find that out. So the mass is canceled out, and this is our final velocity. Now we have to apply the work energy theorem over here. The work energy theorem essentially states that the change in kinetic energy is equal to the work done right over there. Change in kinetic energy, we can rewrite that as, and honestly, let's start replacing values. I know that this mass is not going to be m, but rather it's going to be m plus 2m because now it's that big block over here. So 3m. I know the final velocity, they said right over here, that was 0, right? The initial velocity is right when it starts going on that squiggly line with the friction, and that we found was v naught over 3. The only force that is acting over here is friction, so I'm going to rewrite that as fk. Distance, they said it is d, and cos theta is going to be 180 because friction and distance, they're going in opposite directions. Friction is to the left, distance is to the right. So from here, we have to solve for v naught because in order to find the initial momentum, that is mass times v naught, and we don't know v naught. So we can find v naught from over here. So it's just some basic algebra. So that is v naught, but of course it's asking us for the initial momentum. So we have to multiply this by the mass, and the mass initially of this one right over here is just going to be m. So we multiply m by the initial velocity, and that is our final answer.